The following video presents a practice made by students of Monterrey Tech for the subject of technologies for efficient use of thermal energy. Over time, fossil fuels have been the engines that drive the world. Moreover, population keeps on growing at a substantial pace, as well as energy demand does. Having said that, the implementation of alternatives to reduce environmental impact is necessary. The technological development has led, among others, to search new sources for power generation. Therefore, liquid biofuels and also biomass have become a focus of attention. And one option that can certainly be helpful to achieve this is the real deal of this video. Yes, real deal. The executed practice was about gasification and pyrolysis processes with municipal solid waste. But wait, what are those? First of all, gasification and pyrolysis are recognized as advanced thermal technological processes. With them, it is possible to turn biomass and residual waste into heat, fuel, and chemicals. We mean energy. These processes also provide benefits such as contributing to meeting renewable targets, processing a wide range of feedstock, reducing the amount of waste going to landfill, lowering greenhouse gas emission, and so on and so on and so on. More power generation per ton of waste. On the other hand, municipal solid waste are defined as garbage that comes from homes, business, and schools. One of the major concerns is that as cities grow, municipal solid waste landfills have become an issue for health of people, of land, and of course of air. We mean the whole environment. Municipal solid waste is usually collected from organic degradable, organic non-degradable, paper, carton, textiles, metals, and glass. In the metropolitan area of Monterrey, a previous analysis made in the ITESM showed that from the total collected, 44% are from organic degradable, 16% for organic non-degradable, 14% for paper and carton, 2% for textiles, 6% for metals, and 13% for glass. Since glass and metal can contribute to the process, they weren't taken into account because they don't have organic matter and they don't have carbon and can be decomposed. For our project, the material used to make the representative sample were tortillas, mandarin and banana peel, a PET plastic bottle, carton, and a piece of cotton garment to complete the mix. Also, before starting the whole experiment, we took our organic materials to the oven at a temperature of 70 degrees approximately, with the intention of removing moisture from it, until it reached a constant weight of 142 grams. After this process, our mix ended up with 37.3% of organic degradable, 30.75% of organic non-degradable, 26.8% of paper and carton, and 5.15% of textiles, ready for the implementation of Proximate analysis and the pyrolysis. Proximate analysis is a set of methods to get information about the composition of the organic matter. We prepared 6 samples of 1 gram with the percentages shown, and with the help of the muffle at high temperatures and some formulas, we could determine the moisture, ash, volatile matter, and fixed carbon of our born mix, all of which are chemical properties of coal. Also, one of those samples was put into the calorimeter bomb in order to determine the heat of combustion of the mix. It resulted on 4,600 calories per gram. This means the energy released as heat by the mix. Pyrolysis. For this test, first we put 300 grams of our representative sample of municipal solid waste into the reactor. It stayed for a couple hours. For a couple hours. Yeah, sure. After turning off the reactor, we had 3 residues: liquid, solid, and gas. What really matters here is the energy, so by different methods we obtained the heating values for those 3 types of residues. Those heating values were compared with ones of other fuels in Mexico, and those were the results. With these results in mind, we could estimate the feasibility of the pyrolysis. About 4.65 million people live in the metropolitan area of Monterrey. They produce 4,600 tons of garbage daily. If this amount goes straight to landfills, it's not payable. In fact, as a matter of confinement, we would have to pay 135 pesos per ton to Cimeprode, resulting on 627,000 pesos per day. On the other hand, if we apply pyrolysis to the numbered dry base and after removing glass and metals, which is that one, we, as a company with a pyrolysis plant, could earn up to 50,000 pesos per ton. Almost 6.5 million pesos per day. This is way more feasible than the inaction. And on top of all of this, the planet would appreciate it. Hope you enjoyed learning about our project. Team members Saida, Marta, Jonathan, Anthony, and Luis, thank you all for your attention. Bye!